Welcome back to Air Quality Matters. We already have the tools and knowledge we need to make a difference to the quality of the air we breathe in our built environment. The conversations we have and how we share what we know is the key to our success. I'm Simon Jones, and coming up, a conversation with Eric Malmstrom, CEO of Safe Traces. The thing about innovators is, and by innovators, I mean businesses that have taken an idea and brought it to market, is there's literally nowhere to hide. You have to make it work. You're simply just not around for that long if you don't. So in a space like healthy buildings, indoor air, and this post-pandemic era, when we're still trying to figure out how to connect with the public and business, it's a great perspective to take from someone making it happen. Eric is well known in the sector in the US, firmly in the mix of healthy buildings, standards, and research. His take on the sector is worth listening to, and because of the tech he deploys, a fascinating window into how buildings perform. Safe Traces took an idea born out of biosecurity from 9/11 and today map the performance of a wide variety of spaces, from schools to offices to pharma. There's some great insight in this one from someone who thinks deeply about understanding and improving the spaces we occupy. I really hope you enjoy it, and please don't forget to check out the sponsors in the show notes and at airqualitymatters.net. This is a conversation with Eric Malmstrom. So what I thought I'd do in our conversation is normally I wouldn't lead on the company, but I think because what you do is quite specific and for a lot of people wouldn't be obvious. Mm-hmm. I think it's an interesting context to set at the beginning of the conversation, because I think it informs the position and the framing of a lot of how you view the window that you view this stuff from. Mm-hmm. Because I think you're laser focused on the coalface here and on deploying technology. It's more than just deploying low cost sensors. So right. I think that just that context setting or that explanation would be really valuable for people. So perhaps let's start there. What is Safe Traces and what was it born out of, and where are you now with it?
Yeah. So Safe Traces is a biotech company, and I'd say more accurately, a deep tech company based in Northern California that has a technology platform for predicting, detecting, and then helping mitigate pathogen exposures within buildings. Our company was born out of not COVID, but actually post 9/11 concerns about bioterror attacks within the US. If you remember back 15, 20 years ago, after 9/11, there was high concerns within the US at least, and I think many other countries, about anthrax spores and other airborne biological agents that could be used and weaponized against public populations. And at that time, the US government and both the Department of Defense and civilian agencies were interested and concerned about how do we protect the US population and potential attack locations, which were thought to be, on the heels of the Twin Towers being attacked, places like the New York Public Transit System, other high profile locations where you could release something and have a huge destructive impact on the local people. And so there was an acknowledgement at that time too that we were pretty exposed to this risk within the US and other countries, and that the diagnostics that we had for understanding what these attacks would look like from someone releasing something? Where would the anthrax spores or other agents travel in the air? Who would be exposed? And then how would we protect and control this risk? Was something that really lived in the realm of theory, of software models and things like computational fluid dynamics. And there's an acknowledgement that our ability to understand what this risk looked like in real world settings, absent the attack actually happening, was very poor. And so the U.S. Department of Energy, and specifically Lawrence Livermore National Laboratories, which is right down the road from us, started doing basic research on developing next generation diagnostics. And specifically, how do we develop surrogate challenge agents, or things that safely simulate an anthrax spore or some other airborne pathogen that could be a good simulant for that agent, and then be used in a safe way in real world settings to, get to the ground truth of what it would look like, so that we're adequately prepared for when the real thing happens. And so all that is to say that that basic research then gave life to our company, which was spun out of Lawrence Livermore National Labs a decade ago. And over the past decade, we've really advanced that core research into a commercial product that I'd say over the past few years, the focus has been more on infectious aerosols and respiratory viruses, particularly during the COVID-19 pandemic and the aftermath. But we have a technology platform where we can create these DNA tagged particles that safely simulate an airborne pathogen, and also not just airborne, but foodborne pathogens and other modalities. And then you put them in real world buildings and food processing facilities and other real world settings that have pathogen risk. And you're able to then test how well are the controls working, collect data from that, and then be able to then capture that data digitally via a software platform, and not just have an analog report, which is, sitting on a laptop somewhere, or a hard copy that sits in a file cabinet, but aggregating the data in a software platform. So you then can capture this across different test events, across different buildings within a portfolio, and then across portfolios, and pool the data to understand kind of at more of a macro level, how do we do better in different environments across different modalities and spaces. And so that's really, the core of our tech. We offer a technology-enabled service, and soon we'll be releasing a biosensor that does real-time detection for airborne pathogens, which is a technology that is very important, I think, to closing the gap between detection and then mitigation of these risks. And so we focus on that technology platform and then deploying it in a variety of buildings across real estate, ranging from government facilities to schools to military, critical infrastructure to hospitals to prisons. We work in a very wide range of buildings.
That's really interesting. And perhaps to roll back to the very beginning of what you were talking about there, for people who haven't just read Airborne, because I think there's echoes of what you've just said in Airborne post 9/11 and the concerns over pathogens being released into the States and further afield. But to cast people's minds back to then, or for those that weren't really aware or around then, this was a very real risk. I mean, people were being sent envelopes with powders in, and there were attempts to release pathogens on subways and things like that. I mean, this wasn't theoretical. This was people going, Christ, what happens when something is in the air in this complex box of a building? We've got absolutely no clue how this risk manifests and spreads. And so that was A, very real, wasn't it? And B, highlighted a problem that we still understand being a problem today. And that is, we largely don't have a clue how air moves around these complex environments that we call buildings.
Yep, I totally agree with you. When you frame the airborne pathogen issue as more of a biodefense and biosecurity concern versus a public health concern, it changes, I think at least the kind of framework that you're operating in. And, my own background, I come out of the military. I was an Army infantry officer. I'm a combat veteran from Afghanistan. I don't come out of the biochem nuclear warfare arena, but you're certainly, even as an infantry person, trained on, if one of these attacks happens, here's what you do. And you put on a mop suit and you have all these protective measures. But the reason that I just kind of talk about the framing being different is within biodefense, you look at the risk from kind of 3 points of departure. One is naturally occurring, which is the pandemic, depending on your point of view of whether it's a lab leak or something else. But there's the naturally occurring, there's a novel pathogen, it starts spreading, or there's an existing pathogen, it starts spreading from epidemic to pandemic. That's one kind of track. The second track is the accidental, and that would be a lab leak or something where something happens that was unintended but still has disastrous consequences. And the third is the kind of weaponized bioagents, and that's getting into anthrax spores. And there's a long and unfortunate history that goes back in this arena, and it's covered pretty extensively in Carl Zimmer's book Airborne that you referenced, in the whole Cold War era, both in the US and the Soviet Union. There were active programs in both countries regarding bioweapons. And then even before that, and even today, there's still, I'd say, risk from bad actors on using weaponized bioagents as a tool of war, despite conventions that we have. It's something that still we're living with right now. I think that, to your point on we don't know what's going on, I think that I think there's acknowledgement and concern within the national security community that this could be, you think of in things in national security in terms of most likely and most deadly. And I think that the bio risk is something that's checking both of those. Sometimes you have a most likely and least deadly, or vice versa. This is one that is most likely and most deadly, whether it's naturally occurring, accidental, or weaponized. It doesn't take much. There's a low barrier to entry for one of these things to happen, and then for it to have devastating impacts. And the COVID pandemic really has shown that, but that's just one of many examples of pandemics and other bad things that have happened over the past several decades. So, and it's just to me, an unacceptable risk that we have both in the US, amongst our allies, and globally, of these things happening and us really not knowing, not having good early detection systems, or when they are happening, being able to properly respond and kind of operate in a world of gray and not binaries of either do nothing or shut everything down. But what are those in between points, and what data signals are we using to inform how we appropriately escalate and then de-escalate when necessary?
Yeah, and you're touching on one of my favorite subjects, which is risk and hierarchies of control and all of that. And some things are clearly different. The sources could be clearly different. There are values, and infectious levels could be clearly different. The environments that they can be in can be clearly different. But some things are the same, and that's the basics. That you have a source, you have a receptor, us, and you have engineering controls between us and these risks. Forgetting the whole walking around in hazmat suits bit that you had in the military, that for most of us, our buildings are the engineering controls that protect us, or, architecture our outcomes. And that thing is the same. And so regardless of the risk, at some point you've got to understand how those buildings are functioning practically. And that, from my understanding, is really what you've done with your tech. That's the tech piece. It's the ability to release stuff that mimics things that get airborne somehow, and map and pattern how that risk moves through a building or is controlled. And that's the clever, and that's the universal truth, isn't it, of buildings, is that very rarely do we really understand what happens. I mean, we've all seen the movies where somebody opens an envelope and there's something in it, and that everybody shuts that room down and clears the floor. And, that's the extreme example of a risk, an acute risk being in a space
Mm-hmm.
and trying to protect yourself with some form of engineering controls. But the day-to-day risk of infectious aerosols in the air or whatever it is, we need to have an understanding of how these buildings work. And that's really where you've hit the coalface, isn't it? With Safe Traces is a technology that allows you to see the building through that lens. Is that a fair reflection of what you
Yes.
do?
Yes, it is. I think that at this point, I would say that from a airborne infection control standpoint, and this largely goes for commercial and public buildings and controlled environments like healthcare facilities and biopharma facilities and BSL-3 and 4 laboratories are different. But I'd say for most commercial buildings, they're black boxes in terms of our understanding, both at the operator owner level as well as the occupant level. How safe is it? We don't have number one, we don't have basic code requirements that I think really appropriately address this risk from a hazard standpoint and codify this is what you need to do from a basic design standpoint. There is, at least within U.S. building code, a requirement to focus on prevention of harm, but harm is defined as things like mold and asbestos and not kind of viruses and the other more likely and more common risks within the buildings. Secondly, how well the HVAC system, even just the basic space layout and the geometry and the way the space is set up and then it's operated, I think are not well understood in how you reduce and mitigate risk. And then you also just have, I think, a lack of mature kind of quantification, measurement, understanding from an aerobiology standpoint. What are the appropriate risk thresholds? And then in some cases, they're all jumbled together with other non-bio contaminants like CO2, the various PM levels, VOCs, and it's just a soup of things that don't really make sense or incoherent. And so I think that, consequently, the controls across the built environment, broadly speaking, are extremely inconsistent. In some places, we're doing too much. I'd say a lot of modern buildings, we're overventilating them. Even the word ventilation for pathogens, you don't need to just increase fresh air into the space. You can disinfect or inactivate a pathogen that's just using a completely different mechanism versus, removing the pathogen through air changes and other ways. So right now, all of those things are out of whack, in my view. We're needling in the right direction in some respects, but it's too slow. It's still too incoherent. And you would think that after a major global crisis we've had in the pandemic, there would be, I'd say, not only more awareness, but more will and more urgency to protect us the next time. And I think that for most people, they just want to turn the page on this. And we then are kind of left with a lot of the same risk factors that we went into the pandemic with still existing today. And we know these pandemics are going to happen again. So it's very concerning. Where we play a role at Safe Traces is just demystifying in a world where there are not good code requirements or the overall maturity of the regulations and what people are doing is all over the place. We can bring technology and data to bear to help the people who want to do something, to help them do the right things within their respective buildings, and then pattern recognize those across buildings to help inform, I think, things that are going to be broadly applicable across many buildings.
So for listeners that aren't aware of Safe Traces or that type of technology, paint a picture for what it actually is. What are you're nebulizing or vaporizing products, a medium into the air that's traceable? I'm guessing the clue's in the name.
Yes.
That is traceable by other receptors placed elsewhere in the building, and it's that you're using to build up a picture, I guess.
Yep, exactly. I'd say that one analogy, this may not resonate with everyone, but in medicine, you have PET scans and CAT scans and MRIs, and PET scans in particular use a tracer technology that are put into the bloodstream and help you do both preventative and then curative type treatments to the body to detect disease and then figure out. And if you think about a building in the same way you think about a human body, we're using a tracer technology. So we use DNA taggants on particles, whether it's a liquid particle that then becomes aerosolized to simulate safely a respiratory virus, or it's a solid particle like an anthrax spore surrogate or a bacteria or something else, and you're injecting this into the air. It's safe. It's all, using food grade materials, but you then are able to kind of test the kind of circulatory processes of the building, which is the air and, the key organs, the HVAC system, basically release something and understand what's the flight path of the particles within the space. And that matters in how you actually operate the systems in a way that is health centric. How do you reduce exposures to bad things within the air and be much more sophisticated about how you do that? Our DNA tagged particles are a mechanism to figure out really how is the air moving around, and doing it not only in a health centric way, but also more geared towards the occupancy of the building. When you're taking a measurement of airflow at the supply register, or if you're going up to the actual air handling unit, that's all then flowing air into a space that people are sitting in. And the question is, what is actually happening in that space to the point that people are going to be breathing things or doing something within the classroom, within the conference room. And so we do controlled releases of these DNA tagged particles in the space to, in some ways doing basic checks. In a room, if you have a sick person, you release DNA tagged particles through an electronic sprayer that shoots out 5 milliliters of DNA tagged particles. It's simulating a sick person coughing or sneezing in the space. You then test how quickly are those particles clearing in the space. You then do that across a number of spaces in the building to say that you're meeting a certain CDC, ASHRAE, WHO kind of standard or guideline. You also can test if a sick person is in one part of the building, how is it spreading within that space? And then how much is getting out into other areas of the building, and having a quantifiable way of understanding that. And then, giving people back visualized analytics that in a heat map or traffic light format to tell you red, yellow, green, or you're above or below a certain performance bar. And I think that all of that stuff seems basic at one level, but for the most part, it's not done except in a very small minority of buildings that are being very proactive about managing this risk. So I think, that's kind of a summary. I mean, from an equipment standpoint, we have a sprayer, we have a liquid water solution that has DNA taggants in it. The sprayer releases the particles in the space, and then we have industrial hygiene kind of pumps, or we have a 4-channel air sampler that's using a filter cassette, and it's reading the DNA levels within the space and understanding the decay or inactivation of the particles over time in a way that you kind of start from a starting point or a baseline. What do things look like over time and space? So how quickly are you clearing, or how far are things spreading, and then linking that to kind of risk thresholds within the space.
That's interesting. There was a couple of things I picked up there. So practically, for people in their mind's eye, if they don't go and have a look at the links in the show notes of your website, there's basically a box that nebulizes, sprays stuff at a point that it can be suspended in the air and travel with the air around a building. You have a number of receptors or devices that measure that you place around a building for a period of time, and you would run a series of tests in one room or one area and move and kind of map the building out in some way. So I think we can get that. You said that you're able to both detect the absence or decay of the tagged sample in a space, but you can also sense the deactivation of it. So it's still there, but it's deactivated in some way. that's quite a 3D picture, isn't it? Because you're picking up both the removal of that product from the space, but perhaps even the deactivation. So for people thinking things like UVC or far UVC or ionization or, bipolar or any of these devices that are deactivating biological material, you're not only able to see the lack of something, you're able to actually see it present but deactivated in some way.
Yeah, and that's a really important point. Thanks for picking up on that. Our tracer is the first and to my knowledge, the only challenge agent out there that can help measure the germicidal efficacy of upper room UV at 254, the more common long-standing UV fixtures within buildings. Also the 222 far UV, which is at a lower wavelength or lower nanometer, but also not just beaming the top of the room, but beaming, having more exposure to the people, which is something that is, I'd say, a very interesting and potentially powerful technology for both protecting humans and then also protecting animals. And we're starting to see the rise of that. But what we do for UV is we can measure the damage to our DNA and correlate that and then, quote, dose scale it to pathogens of concern. And this gets to another really important point. There's a lot of discussion within aerosol science and infection control on particle sizes. And a lot of these things, whether it's sub 1 micron, 5 micron, that discussion to me, I think misses one of the key points, that the dose for something that's infectious, or when you're talking about a pathogen, the dose matters, not the particle size. There is a linkage between the two, but you want to know how much dose you're exposed to then understand, is someone going to get infected? And it goes from exposure to actual transmission. What the UVC is deactivating the pathogen, but it's still present. It's just not infectious anymore. And so by being able to use our tracer to simulate that, you're not going to use real pathogens in a real world space outside of someone naturally being sick there. You're not going to commission the building releasing, COVID or RSV. We can use our tracers to understand how these fixtures are performing. And beyond that, how do you optimize their performance? Where do you put them? Where are they going to be most effective? Beyond just their efficacy from a standalone product basis, you have to understand how they work in the context of the room design and geometry, the airflows, and all sorts of other things. And so UVC, for the most part, is tested with pathogens in test chambers or placed non-real world settings. And then that's extrapolated out to the field and to the real world. And then to the extent that they're tested at all in the real world, you're using radiometric measurements and testing the kind of light and energy intensity, but you're not really testing the core claim that the manufacturer is making, which is that these things are zapping the viruses in the air. And so we provide a way of doing that. And that really completes the picture, I think, because by testing both pathogen removal and inactivation mechanisms, you're holistically understanding how are all the different controls working within the space, and then figuring out what role and what contribution does each have, and then what's the right kind of recipe for the building. Because if you don't want to throw everything at the problem. In some cases, if you're using UVC, you can dial down the ventilation in the space and have something that could be for pathogens more effective, but then provide an energy and cost savings that then is holistically addressing the building concerns from both a health and safety side and then a cost and energy side.
Yeah, and I suppose you're providing another really important building block into understanding the genuine performance of buildings, outcome orientated performance rather than regulatory or standard related performance. And that's key. We're seeing that across the chemical space and the gaseous space in monitoring, and one of the big missing jigsaw pieces has been the bioaerosol space, trying to understand pathogens and bacteria and viruses and so on. And ultimately, we don't mind how we get there. The important thing is outcomes, and to understand how spaces are performing. So the more tools we have in our disposal to fundamentally understand how a space is working, the better, right?
Well, absolutely. I mean, I think to just pick up on something you said, I mean, particles, bioaerosols or pathogens for the most part, and then gases all have different control mechanisms for them. In some cases, they overlap, but they're all a little bit different. And if you want to be holistically improving indoor air quality within a space, you need to be thinking about each of those kind of categories of contaminants. And then for each, the control strategy needs to be holistically addressing all of them. And I'd say that bioaerosols have been the kind of squeaky wheel in that equation because they're so complex. And so they've been neglected, and it's just assumed what you do for particles and gases are going to be broadly good for bioaerosols too. And that's not the case. And at least for the inactivation, and the UVC and other things that have a germicidal kind of benefit, it's just that's unique to bioaerosols and not as applicable or not applicable at all for particles and gases.
Yeah, and it enables you at the very least to be able to have a grown-up conversation about how to operate spaces. We've spoken before about the limitations of standards and codes and building the business case under things like WELL and LEED and so on. We've got all of these levers we're trying to use to either determine through the stick or the carrot how our buildings should perform. But the more ways we've got of seeing and visualizing how spaces perform, the more sophisticated and nuanced the conversation we can have. Because like you said, many of the buildings that you're measuring may be overventilating, and we're not devolved from the energy crisis and managing our sustainability of buildings and so on. In an ideal world, we'd ventilate 5 times more than we're doing, but we don't exist in that world. And certainly in some parts of the country, that's felt very acutely. We have to be able to see buildings in the context that they're in, have a grown up and nuanced conversation. And ultimately it all comes down to, you can't manage what you don't measure. And so the more ways we've got of measuring these spaces, the better. I guess by doing what you're doing, you're also picking up a lot of the fundamentals as well. I mean, at the end of the day, this is kind of tracer techniques, which also enables you to visualize decay and air change rates and energy performance of spaces. And because with an air change comes a loss of energy and so on. So I imagine, notwithstanding the infection risk profile that you see, you're also seeing quite a layered set of data on a whole range of other metrics that would be valuable for building operators and owners.
Absolutely. I mean, we work hand in hand. I mean, we're I'd say a critical and historically missing part of the equation of an overall system, but we work closely with companies in the IAQ monitoring and sensing space, and both in terms of the ongoing our measurements versus their measurements in the space, but also overlaying the data, our data with their data, understanding kind of to what extent some of the big questions that are very active in our space of to what extent is CO2 a good proxy for ventilation and for kind of infection control. There's a whole camp of people that think that it's imperfect, but still it's, good enough. We have done a lot of studies looking at CO2 versus our biosensor, our bioaerosol challenge testing, and seeing to what extent do we see that borne out in our data. The same thing with PM 2.5, the same thing with air change rates. All of these things, I think, both from a measurement and monitoring of the space, and then how you interpret the data on the backside, and understanding what is working versus what is not. I think it's very critical. We don't claim to be the holistic answer for all of a building's indoor air quality, problems. But I also think that our view is that by not using something like us and just relying solely on CO2 or PM levels or a combination, you're missing some very important ground truths and realities within the building.
Yeah, and this is not a product in development. I mean, this is out there on the coalface being deployed right now. As a customer, how's this translating into tangible outcomes for me? So what are you seeing practically when you go into a range of buildings? So maybe explain the kind of buildings that you're finding yourself going into and the kind of things that you're seeing, or the value that you're starting to find for people.
Yep. So we have worked in a huge diversity of buildings, and at this point, tens of millions of square feet. I know you're in Europe and the metric conversion, but we've been in lots of buildings and we've done.
It's about 100 liters, I think, in European.
Yeah. So anyway, I mean, as you say, the basic point is that this isn't a bunch of clueless scientists kind of tinkering around in the lab, and then we've done a couple pilot projects. We've done a lot of work particularly over the past 5 years. And to your question of what types of buildings, I'd say that it started off, I mean, where things really picked up for us was in the pandemic 2020 period. We started off, I mean, just to give you an example of some of the first three kind of environments we were in a large corporate office initially in Silicon Valley in California, where we're based, to help them reopen after we had shelter in place orders and buildings were shut down in California for the most part. We then followed that by going into a large prison that was having one of the biggest super spreader outbreaks in the US. I think still it's, in the top 5. And then we followed that by going into warehouses. And then over the next couple of years, we were in mass transit, office, corporate workplace, industrial sites, and then healthcare. I'd say that by 2022 or so, as we were kind of out of the worst of the pandemic and things were reopened or broadly reopening, we saw an evolution away from our work in the corporate spaces. And schools are another important area that I should have mentioned. We've done a lot of work in schools, but over the past couple of years, a lot of our work has been in controlled environments. So I'd define those as healthcare, life science facilities, biopharma laboratories, and especially ones at the BSL-3 and above level where you're handling pathogens within them. I'd say that is where our technology has really, from a technology standpoint, has strong, quote, product market fit, because all of those facilities are designed to handle or to mitigate exposure to pathogens, whether it's protecting people in a healthcare facility from exposures, to protect product, in pharmaceutical from contamination. Or the other category is critical infrastructure and military and government installations where they need to remain open. And I think that those places just put a much higher value on protecting the people and the products within the facilities. They're designed and operated with those considerations being very fundamental. There's compliance requirements that those facilities have that other buildings don't have, and that you don't need to convince them that they should be doing this. They get it. And you're speaking to generally a more technical audience, not just a standard facilities manager, but someone who has special training and is generally more sophisticated, both mechanically, but also from a safety and biosecurity standpoint. And that's huge, because for us, it's like we definitely can continue to simplify what we're doing, because you start getting too technical with people, they're not going to get it, their eyes are going to glaze over. And if they don't fundamentally understand it, they're not going to use your product in their space. So we've had to constantly just cut out the jargon, simplify it, make it but those other communities, we don't have to do as much of that because they're speaking our language and vice versa. So I'd say that's where we see the big opportunity, and I'd say the durability of the market. I'd say, unfortunately, the commercial buildings and schools, just due to, I'd say, challenges that they have within those markets. I mean, it's well documented at this point that office occupancy in the US and many other countries has not rebounded to pre-COVID levels, and you have high vacancy rates. And so when the buildings don't, that's hitting the economics of the building, and they're going to be fundamentally defensive about anything that any OPEX or cost that isn't required. They're going to question, why do I need to do this? Schools are constantly budget and cash strapped, and also are dealing with a very bad deck at this point of having old kind of, I'd say, dilapidated buildings and not enough money to fix them. So, there's, I'd say, a variety of different considerations into where we focused. We continue to want to work in those other types of buildings where even the market conditions are not great today, but it definitely is an uphill battle in many cases to do so.
Yeah. I'm fascinated to break those down into two camps. So in the buildings that you're working in, and it makes complete sense, those buildings that are designed to hold, separate, and remove you from various different risks and pathogens and so on, like, completely get it. You get to play with a scenario that doesn't carry any risk and understand the performance of those spaces. And you're like you say, you're talking those people's language. Are you finding that in the majority of cases in those buildings, it's a checkboxing exercise, that you're really just proving that the mechanisms that are there are effective and there might be a little bit of tweaking? Or are you finding some common failures or surprises in those kind of environments where people just don't have a hold on what they thought they did?
Yeah, that's a great question. So to the extent that I can generalize, I would say that the controlled environment facilities are really a story of overventilation, overperformance, over engineering. They are have in many cases too high air changes. They have too high, the filtration levels. In many of these environments, they require HEPA level filtration or something, well above where a commercial building would require at MERV 8 or MERV 11 or 13. I think that the out of the different controls, the ventilation often is higher than what we think is justifiable from a pathogen control standpoint. And the way that we see that is when we test these buildings at their current baseline. And let's say in an operating room in the US, those spaces are required to be at 20 air changes. We see them, and that's the number is actually even higher when you consider and credit in the calculations the filtration impact and other things beyond just the ventilation rate of the building. But we can see performance anywhere from 10, 15, 20% above that 20 to then 30, 40, 50, 60. And in laboratories, they can go even higher than that in some cases. And then, in some cases we test current baseline and quantify that. And then what happens if you drop down to a code minimum? And we see from an aerosol removal standpoint, very little difference in terms of the performance. The difference, I call it the diminishing marginal return of increased ventilation over a certain level. Cranking it up further just to be safe or to be extra safe is not really doing you any favors, but it is coming at a very high kind of price and energy cost tag and penalty. The other thing, though, is that, in other types of controls like pressure controls, where either positively or neutrally or negatively pressuring a space. A lot of those spaces are tested under static conditions where the doors are closed. And the big question that we have, and that I think more thoughtful people in those spaces who work in those spaces have, are, well, static is really not what the real world is. People are coming in and out. Those switch the pressurizations. And so what happens when the door opens and closes? How much escapes out? What gets in? Also, the whole area of resiliency and what happens when you have to kick into a different mode, where in California and now increasingly other parts of the US are dealing with wildfire risk, and you have particulates from smoke coming in. And then that also happens during a flu season or something else. What are you doing with the building? Because you're not going to be bringing in so there's just so many different challenges. And then there are other ones, like the power goes down and you switch from, main power to generator and then back on. And all these things you have to kind of, and in many cases, the types of facilities that we're operating in have to test either proactively, or they're required to test what's going on in those instances, because they're not just unlikely events. They're becoming increasingly likely events. And so we find that it's a mixed bag. When you're testing more to real world conditions, the ground truth, we're generally not finding these spaces are just, I'm going home, freaked out about what's going on in these spaces, and then the people are kind of getting a failing grade. It's more shades of gray, but I think that you pick up things through more real world condition type testing and using our technology than you would with just the kind of legacy standard check the box ways of testing the facilities. But I'd say that, again, overall, from a ventilation rate standpoint, many of the controlled environments are overdoing it. And one final point I want to make on this is that within a hospital, the operating room, or the compounding pharmacy, or the airborne isolation infection room, you don't want to mess around there. Even if there's a benefit of reducing air changes or tweaking something to be more efficient, you may not want to do it. The question I have is in the corridors, in the non-critical areas, where often we see many of these same overperformance issues. What is really the justification for doing that? There isn't one in my view. The problem is that at this point, it's just so hardwired into how the facilities are operated that getting the changes made often is complicated. You have to take it from facilities to infection prevention and control. And, at some point the thing just kind of fizzles out. And so consequently we just have, areas where there's not a good case to have them overperform, continue to do so. And so I think that's one of the kind of maybe surprising benefits. People often assume the worst with our data of, oh God, you're going to show us something really bad in our facility. And the bad thing is, like, hey, you're doing things that can actually, if you adjust them, you can adjust down or save some money. And I think that that's one of the big barriers, I think, and one of the big misconceptions for any IAQ. It's basically going to lead to more cost, and my building is going to be shown to be deficient. And then you're going to create a problem for me, or a Pandora's box. And I think that in many cases, the story is a lot better than that. That is not the case for schools, for like all the less modern buildings. Often we do see problems in those buildings, but in the controlled environments, I think there's a lot of efficiency opportunity just sitting on the table for the taking.
Yeah, and we'll come on to those other buildings. But there was a couple of things that were making me smile there. One was the trope of the engineer, and that is unrestrained. The engineer will very accurately calculate what's required and then just double it to make sure he doesn't get a callback,
Yeah.
and to be fair, I want an engineer to build in some redundancy for earthquake protection. I want an engineer to build in some redundancy for electrical safety and fire safety and ventilation, to be quite frank. So I think that capacity in design is good. I think the challenge, and as you point out, is that the equal trope of an engineer is they'll make their life as easy as possible. And if it's easier just to make the whole floor ventilate at 20 air changes per hour rather than thinking about in zones and then handling and managing pressure differences and volume differences between spaces, why would you give yourself that headache? So that demand control element and that ability to separate and look at the use of spaces. And as we know from buildings, often people are designing HVAC and airflow for buildings before it's completely clear what those spaces are going to be sometimes.
Right.
So there can be changes in use over time, even within a space. So I think the lesson from even those high performance buildings is that capacity and adaptability of those spaces, that they can be engineered in the moment to deliver what's needed. And with the advent of technology like yours, you can see how those spaces are performing and modulate and alter them accordingly. It doesn't mean you don't have that capacity, but it means you can make it appropriate for the moment. But you may not have that ability in the design. Often, particularly in these bigger buildings, they're not that definitive in your ability to alter flow rates. Often you find there's only a few dampers on a floor to play with,
Exactly. And that I think that's a really important point too, that even in the most modern buildings, they're not these nimble, agile, highly dynamic systems that can change on a dime. A sensor picks up something and then you're going to have in a very targeted location in the building something happening. To the extent there's kind of, I'd say, some version of that exists, but not nearly to the extent that exists in kind of other technology areas where you can be very dynamic. And so I think you have to operate from that point of departure, that both in the building design and then in the operations, the simpler, you want to really understand what is optimal for the baseline normal condition and run the building at that level as much as possible to make life easier for the building operator. And how you think about doing that, you need to be, addressing all the different concerns, the thermal comfort, the energy, the indoor air quality. Indoor air quality is just one of several parameters. But that being said, where, to the extent that IAQ has been not a part of that equation, it should be. And then also it needs to be weighed against all the other factors. And we cannot be in a situation where we're just laying on all these complexities to the building in a way that the person running the building is just not going to be able to manage, or is completely unrealistic given the capabilities of the building itself.
In a way, but to push back against that a little bit, my expectation of an asset that's far less valuable to me than the building that I own, which is my car, is my expectation of that car is that it has over-the-air updates. It's enabled to understand the driving conditions that it's in and adjust brake pressure and suspension pressure, and it understands oil viscosity and when it requires a service. It knows how to present information to me simply that I can make decisions in the moment, but it's running background diagnostics at 1,000 times a second that I don't get to see. A technician can plug a computer into it and know everything I've done over the last 6 months of driving it. Our expectation of technology and assets seems to me to be completely misaligned. Why our building isn't assessing outdoor pressure conditions and environmental conditions and uses of spaces and adjusting at 1,000 times a second to deliver perfect outcomes for us, considering the impact it has on our long-term health and well-being or our vulnerability to infection risk and stuff. It just seems to me that our expectations are completely screwed. We're quite prepared to spend 50 grand on a car or 100 grand on a car, or whatever your budget is. And our entry level expectation of that asset is like 100-fold performance wise and automation wise than we expect out of an asset that's sometimes 100-fold more expensive. It's bananas, isn't it?
It
in
is.
that
And so
sense.
I agree with you. I guess that my point was that to me is a failure and a problem at the building owner level, and then the designer and the architect, not the facility manager, because they basically are handed this building, which has been in many cases developed to a lowest common denominator. For the building owners, it's a financial asset. It's not something that is thought of as a product that actually the people inside are using. And therefore, then you have all the problems that you just called out. And the fact that I think the car analogy is really good. And we use that one ourselves too, to talk about, tuning up a building versus tuning up your car. It should be clearly happening at least once a year, for a asset that's going to have a multi-decade lifespan, in some cases far longer than that. It's not much to ask. But at this point, one of the key questions that I think about a lot is, how do you get there? How do you get there from where we are now, where the expectations are so low and we are doing so little? I mean, I come out of, prior to Safe Traces, I come out of the food and agriculture world, and even Safe Traces has worked in that environment. You go to food processing and handling facilities and animal handling facilities, you have USDA and Food and Drug Administration inspectors all up in the business of the people who are running those facilities, auditing them, checking them, fining them. And then, so that's kind of a world I come from. I go into the real estate world and I'm like, whoa, free lunch. There's nothing really required here. It's shocking to me as I've dug more into this. And the question is, how do we get from where we are now to a place? I mean, maybe it doesn't need to go to the same level as food handling facilities, but surely it needs to go beyond, basically nothing in many buildings today.
Yeah, well, I mean, there's been some great work done by Max Sherman and Ben Jones and others on the harm intensities of pollutants in the built
Mm-hmm.
environment. And, when we translate it to a public health metric, according to the work that they've done, it has the equivalence of smoking. It's twice as harmful to us at a population level as road traffic death and injury or
Right.
alcoholism. And we spend an absolute fortune on those. You just think of the resources and thought and consideration that goes into road traffic safety and road safety measures and car safety and so on, all trying to bring down the disability adjusted life years of that risk down to a tolerable level. And we still consider that work not to be done. Um, Yet our buildings are causing us twice the harm of that. And we're not even scratching the surface of the kind of input and resources that those industries face or are scrutinized under. So it's amazing, really. And then it leads me, it's a beautiful segue onto the other part of the building stock, or as Joseph Allen says, the long tail of the built environment. Not your Deloitte's headquarters in New York or your pharmaceutical facility in the Midwest. Your K-12 school or your office above a warehouse in an industrial estate somewhere in Texas. These are the buildings where the low-hanging fruit is. These are the buildings where people spend their careers working in suboptimal environments or as kids when they're most vulnerable, spending, nearly 2 decades of their life in spaces that, can potentially cause them harm. I'm guessing you got if a brief window, a window nonetheless with Safe Traces into looking at how those spaces performed during and just post the pandemic. I'm guessing that was a bit of a different picture you were seeing in those spaces to your Pfizer manufacturing facility.
Yeah, absolutely. Um, let's just pick up on schools, because that's an area where we continue to do a lot of work, and beyond just our work as Safe Traces. I feel so strongly on the school issue. I have young children. I have a 7-year-old daughter, a 5-year-old son. We're they're fortunate to go to a good school district where the facilities are a lot better than many other parts of the U.S. But the U.S. just, it does every couple of years, the American Society for Civil Engineers does a report card for U.S. infrastructure. Schools, again, just got a D plus. It's the second largest public infrastructure category in the country after highways. It is a disgrace, in my view, the conditions of school facilities in our country. They are chronically underfunded. They are chronically under maintained. They are completely set up for failure. And it's also, there's a huge equity angle to this, given the way that school infrastructure is financed within the US. It's largely a local concern through local bonding. And so you have a world of haves and have-nots. Rich communities bond, and then they have nice facilities, and they have the money and the resources to make nice facilities. And then you have lower income, underserved areas, both in cities and rural areas, that the conditions are not places where kids should be going to school in. And I think that when we go in, we've seen the whole range: urban, rural, modern, not modern. And I'd say that, being a little bit more optimistic, but not naively so, I'd say that some schools, even ones that we went in thinking, wow, this is going to be very bad, it was pleasantly surprising that, at least in terms of when we measure to, are they hitting the CDC recommended equivalent air change and ventilation rates, it's not like the whole school is failing. It's like certain areas, and then they can be targeted. But of course, to the extent that we're not prioritizing this, and, from a school perspective, they feel like, whether you're an administrator or a facility manager, they just feel like the facilities that they have, they're not oblivious to the problems, but also they're taking heat from the local community. They are taking heat in the media. And so they're kind of at an impasse of, what do we do? And with that, they view things as not being properly resourced. And then, until we can actually get a lot of money to then fix things, then we're basically going to be resigned to having very bad mechanical systems and bad ventilation, but there's nothing we can do about it. And I think that probably misses some key points to me, which is, it's not all about resources. Even within bad buildings, you can do things that meaningfully improve the indoor air quality, and things like the Corsi Rosenthal box or other low-cost things can really move the needle and make things a lot better. The secondly is the resources that we've provided. The pandemic is unfortunately a case in point where a lot of stimulus money was provided that was either not used at all or not used well. And so we miss that. And that becomes then a weapon for people who think that school systems are not, responsible at handling resources, to then say, well, we can't just give them money because they're not going to use it. So there's a whole political angle. But at the end of the day, I think that we have to, this is really a public issue that needs to then create more pressure on politicians at the local level to do more. Because I think that, me as a parent, and I think a lot of other parents, you're just resigned to the fact that the school facilities are not up to par. Your kids, we see the impacts of that, not only in kids getting sick and then bringing it home, but also high rates of asthma, all sorts of other issues that come from poor air quality, with indoor air quality within schools. But then we just accept it and move on and kind of price it in, instead of then saying we need to do something about it and then really affect the change that needs to happen. But I think that, that is, I'd say, a failure of organizing and actually creating a kind of more of a movement and a coalition to change things, to then affect the change and get some small wins that then can develop into bigger wins. And, I'm going off on a tangent here, but I work on the board of a group called the Build America School Infrastructure Coalition, which is representing industry and environmental groups and civic groups, basically to, try to get movement on this issue. But, to the extent that there's not a concerted effort to change things, then it will just stay the same. And so anyway, we kind of see it from a number of different angles. But I think you can play out some of those same dynamics in mass transit, low-income housing, the prison systems. Many of the quote have not areas of the built environment struggle with these challenges. And then those have really damaging impacts for certain vulnerable populations within our country and globally.
Yeah. Yeah. And as you say, often it's the simple things that can have a big impact. And talking of which, slight segue, I've noticed my red lights behind me on my air quality monitors as the air quality expert subtly moves over to his window and lets some fresh air into his office. It just goes to show that
that wasn't a plant. That wasn't a plant.
Yeah, but I think to your point, Eric, it's really true that, I mean, the one thing we got to recognise in a lot of spaces, and schools are not alone in this, is that they're fighting any number of battles. And quite frankly, air quality doesn't even make it into the list of the top 10 that they have to fight that week. In school cases, my local school is begging parents for money for books and pencils and basic resources, never mind advanced HVAC systems and improved ventilation. So, we always have to bear that in mind. But there's also a huge social justice angle to this as well. And, for me, that's what always hits home to me from different angles. One, that kids, when they are at their most vulnerable, are potentially being exposed to environments that's laying the foundation for long-term harm. And we see that in the development of asthma and respiratory conditions, and if a school is contributing to that, that's the exact opposite of what we expect from a public space.
Right.
But equally, at the other end of the spectrum, the school environment, a friend and colleague of mine, Adam Taylor, put this very well, that a school environment can be the only good environment a child sees in its life as well. It can be a place of warmth, a place where they get food, a place where they get to breathe good air that isn't laden with mold and pollutants. It can be the opposite and should be the opposite for a lot of kids, and isn't. And that's a miss as well, I think, from an environmental and social justice perspective, that the space that we create to protect our kids and educate our kids become the opposite, or don't fulfill that promise in some way, know.
I agree.
And as a measure of society, to get that wrong, you're failing really as a society. If you can afford to do it and you're not, I think you got your priorities mixed up somehow. While I have you, I just want to borrow your attention for a minute to tell you about Erico, a partner of this podcast. In fact, I worked for Erico for over 12 years, so I can speak with some authority here. With over 40 years of expertise, Erico has undoubtedly established itself as a market leader in DCV technology. That's demand-controlled ventilation. Their mechanical extract systems dynamically adjust airflow rates based on real-time needs. And their MVHR systems further enhance energy savings by recovering heat while delivering fresh, filtered air, both creating comfortable and sustainable environments. Their advanced solutions are tailored for residential, commercial, and educational settings, ensuring optimal indoor air quality and energy efficiency. As part of the Aldis Group and based in Paris, France, Erico continues to innovate and set benchmarks for the industry. Their solutions seamlessly integrate into buildings, providing intelligent, efficient, and reliable ventilation tailored to the unique demands of each space. With a global footprint, Erico, as part of the Aldis Group, are a powerful partner in securing good indoor environments and are well worth checking out. Links are in the show notes at airqualitymatters.net and, of course, at Erico, spelt AERECO.com. Now, back to the show.
Right. I think that just back on the your prior point on the indoor air quality not really being in the top 10 of concerns, I think that at one level I agree with you, but then the point where I would just challenge it is if out of the water fountains within the school you had dirty water coming out, or if you had kind of wilted lettuce or, food, rotten food kind of coming out at lunch, that would be an outrage and people would have a certain reaction to that. The problem with the air, unless you're dealing in kind of a climate, either outdoor air pollution or fires or something, the fact that the risk is invisible in many cases, I think just causes it has a different psychological impact or lack of impact, and it causes it to be devalued. And that's one of the things that us in the indoor air quality space, whether it's with Safe Traces and us being able to visualize what's going on, or even what just happened a few minutes ago with your air quality sensor going red and showing people in the room that you're above, some contaminant level. I think that that's really important to help show people, because we know that when it gets to basic things like how students perform, even the illness-related absence, which is a key driver of budget levels in schools within the U.S. and the average daily attendance, especially within the peak flu season and other respiratory viruses, that is really hitting the school's budget in a negative way. And so, the question is, do we show things through, dollars and the impact? What's the way? Because I think that most people would agree with you, it's not in the top 10. My point is it should be in the top 10 because it is so closely related to so many other things that are really driving the schools, at both the administrator level and then also the parents and the school boards and elsewhere.
Yeah, and the thing I've never understood particularly about schools is it can be a heavily unionized sector, certainly in some parts of the world. And I think we forget actually that schools are workplaces too. And to be frank, if I was a teacher and my workspace was being shoved in a room with 30 Petri dishes every bloody day, which is what being a teacher is virtually, I'd want to make sure I was relatively well protected.
Right.
This is a worker rights thing as much as that. And the pandemic taught us that to a degree. You started to see the teaching unions cop onto that a little bit. And certainly in the UK, there was like a group union letter to help teachers advocate for better air quality in their classrooms. But I don't understand how that's not front and center. And at the end of the day, schools are unique environments for that. There's very few workplaces where you get crammed into a box with 30 snot bags for 8 hours a day. I'd want to know that I was relatively well. Even nurses are not in that environment, to be fair. If you had a ward that was crammed full of 30 coughing adults, you'd soon get the unions, sorting that one out. But somehow we see, again, teachers somehow seem to get the rub of that one. I was also thinking your point on the water and food thing. I was thinking about this the other day, a bit of a tangent, but that's how these conversations go. We often use that kind of water and food analogy. And I wonder sometimes, because I think analogies are beautiful at painting pictures for people. And you're right that, there would be outcry if water came out of the tap with a foul taste or a smell or a look, and likewise if food was rotting on the shelves and so on. But I think the challenge we have with air quality particularly is because it's so long term and esoteric, often the impacts of air quality exposure. For me, it's much more analogous to microplastics being in your food or BPAs or, those kind of things that are invisible, the too much chlorine or lead in the water or something you're not going to see or taste immediately, but is going to have a longer term impact on you. You wouldn't get the outcry there either. We've been fighting fat and sugars in schools for years, and we're still serving it up to our kids, yet we know it's causing obesity and early onset diabetes and so on. So there are those analogies, we're not great at the chronic risk stuff. If there's smoke pouring in through the window because of a wildfire, or the water's coming out of the tap brown, we tend to react. But we're not great when we're told that the thing that we can't taste or see is going to cause us long-term harm. And I think that's the big battle we've got. It's that kind of public health, longer-term, esoteric picture, because you're asking people to change habits and behavior, or invest or sacrifice short-term gain for long-term gain for something that they have to trust you on somehow. And it's a beautiful segue back to being able to visualize the space and go, actually, you know what? And it was the thing I wrote down to ask you about was the how these conversations go, how the pitch goes, because I imagine there's a lot of fear for building owners and operators of what they're going to unpack. And I'm guessing your conversation goes, look, you know what? Often everything's pretty okay, but what we find is that we can spot areas and things that will trip you up that aren't necessarily a big fix, but you won't know until you can visualize it and see it. And I'm guessing that is a very common conversation for you, as it is for a lot of people in the air quality world, that, look, this isn't necessarily the shit show you think it's going to be in your building. Often you'll be doing a lot of stuff right, and we can show that, and you can park that and not worry about it. But what it enables you to do is free up your time rather than running around blind to focus on the areas that do need fixing somehow or somewhere.
Yeah, that's a great question. So I'd say that for the quote have part of the build environment, where the controlled environments are the more modern kind of commercial buildings, I think that the discussion for us has been more about how do you optimize and how can you achieve good indoor air quality. That's a subjective term, but whether they're trying to reference against the CDC or ASHRAE or something else, you're probably overdoing it. And our data can show you that, and then give you confidence that you can adjust down to see some of those dollar and energy savings while still exceeding, or at a minimum achieving, those kind of reference types of standards and guidelines. That's one discussion. For the have not part of the market, it's more about how are you going to prioritize and pick which buildings, where within the building, make smart both capital and OpEx decisions to be able to do something more than nothing, or just continue to live in the world that you live in today, but have a game plan for how you, and a plan of attack of what you're going to do to be able to improve indoor air quality and do things that are kind of low cost, high impact, or starting from that first principle and then building from there. So I'd say that that's, one way of thinking about it. The other way is that it's hard because I think the easier sale and discussion for us is people where you don't need to convince them. They already get this. We're dealing from a technology adoption curve. We're looking at the early adopters. And that's where we should be focusing disproportionate effort, because they're going to get it. They're going to understand the value of the technology. And we're not trying to convince them and move them off a position where it's just like, I don't see the point of this. It's not worth it. All that. At this point, it's not worthwhile for us to be spending too much time with those types of people. The hope is over time that the early adopters then moved, get the second movers kind of along, and then you're kind of getting enough traction that over time you're moving to more of the market. But by taking that approach, you're neglecting people who could disproportionately benefit from our technology and the improvements. And so it's a what side, or, it's a head versus heart kind of trade-off of you have to do things that are smart for the business, but you also want to have the mission and mission impact of how you can help people who really need this more than others. So it's very challenging. I think that, to me, I've kind of come down to the way to raise the floor which I think is much more important at this point than raising the ceiling, is that you have to get you have to increase and kind of perpetuate minimum requirements, code requirements over time in buildings. And that's the only way that some of these parts of the built environment are going to benefit. And it may take a long time. It may be a very tough fight, but that's needs to be the direction that we travel in. Until the minimum requirements exist, then many buildings are just going to get left behind. And then you're kind of operating more from a altruistic standpoint, but from a business standpoint, it's going to be very hard to get things done in those types of buildings.
I was only having that conversation just this week, actually, with the where does the floor get lifted from, and it was the same kind of idea. It's codes and standards ultimately, and what the job of the pioneers and the early adopters is to shine the light and show the way, so that policymakers aren't so fearful about raising a floor in an unfair way, that they can say, look, here are the pathways for you, that it's like a ratchet. Standards and codes, you may only be able to move it a couple of clicks, but the point is, once you've hit a click, it doesn't go back. There is this constant incremental nudge theory of improvement over time. And sometimes you might only move it a couple of clicks on a ratchet, other times you might get a full run in, but either way, you always, there's a gear, a mechanism to it that keeps it moving forward. You were involved in an interesting meeting, I think, there a few months back in Stanford, weren't you, where it was exactly these kind of discussions with Lydia Morawska and others about how we move the sector forward, whether that comes from codes, whether that comes from the business case, and so on. That stemmed, I suppose, the foundation of that was the open letter, I guess. Was that last year now? Time flies by so quickly. I dread to think it was probably last year. Again, Lydia and her open letters. But this was a kind of a follow-on to that, wasn't it? Onto that baseline as to where do we go from here? What do the next steps look like? There was quite a group of people there, wasn't there, for that?
Yeah. It was fantastic. So, about a month and a half ago, there was a meeting convened by a professor at Stanford Medical School and co-led by Lydia Morawska. So Milana Trounce-Buchman and then Lydia Morawska, to kind of convene a cross-sector group of people, not just academics and scientists and technical experts, but also people representing industry, public policy, technology, who I think are looking for people not familiar with the letter that you referenced. Lydia Morawska has been, I'd say, really critical both during the pandemic and following the pandemic in leading a group of global experts on pushing for indoor air quality standards within buildings. And, early on in the pandemic, she published a piece that analogized indoor air quality to food and water safety, and how far behind indoor air quality is and how there needs to be more standardization. And then a year ago, she published a follow-up piece that was called Mandating Indoor Air Quality Standards in Buildings. And it was really kind of saying, how do we go from kind of laying out this is an area of importance to we need to mandate this within buildings. And that article was signed on by the quote group of 36, which include very prominent people in this space, too many to name, but one of our company's advisors, Bill Bonfleth at Penn State, who's a former ASHRAE president, has been doing an amazing job in ASHRAE and academia. Joe Allen, Lindsay Marr, many other people have signed on to that. And I think that, to me, in some ways, I read that letter, even though there's a variety of different viewpoints on what they're advocating for, which is kind of a short list of contaminants that should be actively monitored and managed within buildings based off of the World Health Organization kind of guidelines. Whether you agree with that list or or you have a different point of view. It wasn't really saying, here's what everyone should do. It's presenting, here's a framework for something we could do, but ultimately we need to drive towards mandating this within buildings. And for the most part, that mandatory indoor air quality standards don't exist within buildings today, even after the pandemic. I think that group of technical experts is looking for now either collaboration or potentially handing off the baton to people who are more in the kind of practitioner arena to say, how do we make something like this happen? And understanding that they are not going to be able to do that themselves, but there needs to be a kind of ground game to help move this forward so that we don't stay stuck in a place where we don't have any indoor air quality standards. So in Stanford, we had 24 folks locked in a room for a day and a half talking through kind of Lydia's piece as the point of departure, and then providing different perspectives on what do we think the contaminants should be, how do we put in economic realities into whatever is proposed in a way that's going to be palatable from a building owner perspective. What types of buildings would we look at implementing these in, and kind of prioritizing those. And the end point of that discussion was that this forum has become now an ongoing group that is working to I'd say formalize this framework that's laid out in Lydia's paper, and then start addressing the different pieces of the puzzle, the business case. There's a group that's focused on piloting these within buildings, which I'm leading. And I think that at this point, the ideas are to start on kind of home turf here in the Bay Area, including at Stanford itself, but also in some of the Bay Area cities in Northern California, to try to recruit some different categories of building owners in government and the commercial real estate world to show what this looks like over an initial period. And really, at a basic level, it's just putting in IAQ monitors to monitor the contaminants. And in some cases, many of these buildings already have that. So it's just kind of seeing what they're picking up and understanding from a baseline, are they even, hitting kind of some of the proposed levels or thresholds that we're advocating for. And then from there, showing that through this initial pilot early adopter kind of pool of buildings, can we both scale up within the Bay Area and then also use this as a scalable, repeatable model that can be taken to other cities in the US and eventually internationally. And I think what really excites me about this is our company is involved in ASHRAE and the American Industrial Hygiene Association, many different other fora. I think they're in most cases great, but I think what is missing is then going the next step of let's do something. Let's get out there and do something, and start from start with a bias towards action, and not be stuck talking to ourselves, nitpicking, well, should the CO2 level be X or Y or whatever, but let's do something and then learn by doing, which is really fundamental to any technology startup. It's like you go out, you do a quote MVP or a minimally viable product, you get it out there, you get feedback, and then you iterate it and you improve it. And that creates a certain flywheel and momentum. And I just get at times very frustrated with the technical and standards world about how slow it's moving, how we're having the same debates for years, if not decades. And then consequently, we don't move anything forward. It still stays kind of within this community of people. And I think that I don't really have patience for that at this point. And I think a lot of other people are similarly minded. I mean, this is not intended to bash any of those other organizations, but I also think that it's not necessarily their role to go out and take it the next step. So I'm very excited. I mean, the quality of people and the diversity of their experiences and kind of backgrounds is amazing. And I really have high hopes for what this group can do. But you start small and I think it's going to be something definitely that people who care about kind of mandating indoor air quality in buildings should be keeping their eyes on to track the progress of this. And I think that, it's something that clearly from my own personal standpoint, I believe very strongly and want to invest my own time to see this through. So.
Yeah, I think that's a really interesting. I was going to kind of ask you kind of what was your overall take from it, but I'm guessing from what you've said there, it was just this excitement to take it on from the engineering and academic merry-go-round to implementation and getting feedback. And, that's a conversation I think we've had more regularly recently, is the fundamental one. Are we even talking to the right people? Because I get a bit like you, I get a bit despondent, probably not as despondent as Joe Allen or Andy Pasilli or Bill Blunfleth about being asked whether a CO2. In fact, for listeners, check out speaking to Joseph Allen, and I rather cheekily asked him whether CO2 was a pollutant or not. And you could see his will to live slowly wilting on video. Probably only eclipsed slightly by if you asked Andy Pasilli the same thing, who's been talking about CO2 for about 25, 30 years now at this stage. And it moves up and down from 800 to 1,000 to 1,200 and back down. Who cares really ultimately? I mean, because I understand at a public health level, it can make a very big difference whether a threshold is set at 12 micrograms or 15 micrograms for PM 2.5 or something, right? Whatever, and that's for public health people to figure out what the societal level impact of exposure is to certain pollutants. But at a practical level in a building, the confounding factors that impact whether a building is at 6 or 7 or 8, a factor of 20% more than another number or not, is so far out of your control often that
right.
that obsession with thresholds and numbers is virtually meaningless, to be frank. It's a bit like looking at a TVOC level in a building. It's nearly a worse than useless number to look at. What you're more interested in is patterns and profile and dynamics over time rather than a particular number. But I do wonder, this leap we've got to make, and I've been asking this more and more of people recently, is where's that leap to? Like, who are the people we should be talking to? And I think what's interesting about talking to practitioners like yourself that are at the coalface trying to deploy technology is that you're getting those hard answers back, because you go to the HR teams, the sales teams will go to the HR teams, and because they think, oh, the HR people have got to care about the people in their building. And it's like silence. And they go, well, we'll go to the FM people. They'll care about the building. And they go out there and 3 years later come out with nothing. And you go, well, it's not the FM people. It's not the HR people. Who is it? I know. I'll go to the real estate people. And you go out to them and they don't get it either. And you learn by doing. That is the only way in business, particularly when you've got product and you're trying to deploy. You learn very quickly where this stuff resonates, where it lands, where the traction is, where the resistance is. And I think there's a lot to be learned from industry, both from the gains that it's getting in this sector, but also the friction that it's seeing. And we've seen a lot of that, haven't we, in our sector post-pandemic? A lot of industries shifted to healthy buildings and are shifting pretty rapidly back to sustainability or energy, because they've found that's a pretty dead end road for a lot of them, healthy buildings. It's a really interesting sector in that perspective.
Yeah. And I think that the trade-off between clean and green, I think, is overstated, and that I think there's ways of achieving both, although at times there are going to be trade-offs. But I think there's a lot that the clean side of the house can learn from the green. And that was also a topic of discussion of how did the green buildings movement advance from a generation ago of really having not much support or adoption and kind of operating in a pre-commercial, pre-regulatory environment to then over time achieving some wins, and what was the playbook and to what extent can that guide the path for the clean buildings movement. So that's really interesting. But the other thing I was going to say is that the nice thing is that with industry participants, whether it's the tech companies like us or the consulting engineers or others, often people, I mean, even in this environment, people have agendas. The reason they're going to spend time as a business is they see it in their business interest to do so. But when it starts tipping over to it becomes another fora for you to just hawk your product or kind of get your stuff into a building, then to me, it loses legitimacy. And the nice thing about this group and the people who are involved, and to their credit, was you didn't get that. People were not trying, many of us knew each other. They're high quality people. And it wasn't like, hey, I'm going to do this to go get some big job or sell a bunch of this or that. It was like, we need to fix this. Like all of us are going to benefit if this effort is successful. And I think that was really refreshing, and also kind of rare, because not only do the fora sometimes get hijacked by the commercial companies, but also when they don't engage in the fora, then we're in a every man or woman for themselves environment where you're trying to sell, and then we're all dealing with the same problems of, the commercial challenges and the lack of code requirements and whatever. So I think that, again, I'm very optimistic on this thing. It's definitely a big challenge, but we can learn a lot from green buildings, even in other safety areas. You brought up microplastics. In the US over the past year, we had some progress on PFAS and forever chemicals. I mean, other public health areas have figured it out over time. And so the question is, what can we learn from those other groups to do the same thing for indoor air quality? And really just be brutally honest, practical, and have both a short game and a long game to achieve our goals. So.
And what are the kind of things that you're excited about personally and as a business over the next couple of years, Eric? You've got quite a bit going on one way or the other.
Yeah. So what I'm really excited about is I think that we're at the beginning of what I think is going to be a real blossoming of aerobiology tech. I think that this space is harvesting. You're seeing in the US more public and government investment in this category of technology. And just to describe it distinctly, it's distinct from particle and chemical detection, sensors, and then also how sensors then integrate into software and then ultimately into the building management systems. But again, going back to earlier in our discussion, the pathogen detection ability to do so in a way that is really health centric and that is fast and rapid and that scales is woefully behind. To the extent that we're doing anything, it's settling plates, sitting somewhere, and then you take it to the lab and you figure out the colony forming units, and it's out of the Stone Age, honestly. What I think
that's changing. You think we're heading towards a bit of an event horizon here with that? I mean, I know I get there's some things you can talk about and some things you can, I'm sure. But I get the sense from talking to you privately that you see that we're on a precipice here, that we'll look back in 5 years' time and we're going to see tech on the ground actually providing meaningful real-time information from a biological perspective.
100%. Yeah. I think not even 5 years, within 6 months to a year. I think it's very close. I think that we're at a point where similar to where wastewater surveillance was about 5 to 10 years ago, where I'd say it was something that was pretty immature. Largely, the proponents and users of it were in academia, and over time, it's become mainstreamed, at least as a tool of biosurveillance and infectious disease surveillance, taking samples out of wastewater and then having the ability to pull that not just at a localized level, but doing it in enough places to then develop a picture across a region, a state, a country, what's going on. I think that biosensors are at that point now that wastewater was about 5 to 10 years ago. And I think that you're going to see this tech start hitting soon. You're going to be closing the gap in terms of how quickly you can get results, and then being able to then pair the rapid detection of airborne pathogens with then an ability to then respond to it and do things that don't just have intelligence benefits, but also have infection control kind of benefits to reduce the risk of someone getting sick within the building. And I'm really excited about that. Our company is very actively involved in that, and we will be having a product out on the market very soon this summer, and we'll be able to talk more about that in the next couple months. And then we're also going to be involved in a very big initiative supported by the federal government to this effect as well. And so I think it's going to be exciting. And at this point, there's clearly a lot of headwinds right now within the U.S. from a policy perspective. And I'd say that a lot of the public health community feels under assault at this point. We've had budget cuts and reductions in force and changes in policy directions. But I think that this area of technology is, and this area of indoor air quality, there's a future where it not only kind of maintains where it is, but also grows in importance. The other thing I'll say is that I think that what's promising to me is that outside of public health, the military sees a lot of value in protecting against all of the categories of both the naturally occurring, the accidental, and the weaponized bioterror. This is something where the military is prioritizing this area for new technology development. And we're involved in the defensive side of that, of how do we prevent these things from happening and preventing exposures. So I don't think it substitutes or compensates for some type of pullback from the public health community. But if we could have the military and the public health community, coordinating and cooperating and collaborating, I think that really would be a strong foundation for then government to support this area, and then eventually for the private sector and both private investors and industry getting more involved. So I'm bullish, I'm optimistic. And this is also not just based on good vibes, but it's something, it's business benefits that we're already seeing today.
Yeah. So I'd encourage people to watch this space, because I'm sure there's going to be some pretty cool announcements. And I can tell you're a CEO. That was a beautifully, elegantly negotiated description of the US context of funding and economic status. Well done. That was brilliantly done. There's probably several layers blunter of a way you could have described what's going on at the minute, but it's certainly challenging, and I think you're right. I think the military side of that is fascinating as well. And for those that have read the Airborne book by Carl Zimmer, there's a history of that within the military as well. They're invested in protecting, from a security perspective, the nation, but also they've got a massive operational element to their organization that they need to keep at full operational readiness and performance and functionality. And they've been doing that through all of the conflicts through history of being at the forefront of public health and medicine and health and keeping spaces fit, because they've had to. If you don't have personnel in a position to do what they're supposed to. So they can be a real leading light beacon in that respect, the military, not just for the the subversive military stuff that everybody imagines, but actually just from the fact that they've got a massive functioning boots on the ground operational element. And if they don't get it right, they're in deep doo-doo and right quickly. So they have to be flexible in that respect, in that way.
Well, and the question is, why is that type of prioritization and mindset not, it's immediately transferable outside of the military to, you need your people healthy to be performing at work, to performing at school. It's just the military is maybe not the model for other things that we would want to do outside of the military, but also the ethos of getting things done, valuing the people in a way that you want them protected, the whole concept of force protection and then force readiness. You take those terms and put them into more of a health and safety context, it's immediately transferable. So I some ways maybe we can help bridge that divide a bit. But the other thing I'm going to say is that just on the public health side, I think there's a healthy reckoning going on right now. At points it becomes unhealthy, but coming out of the pandemic, some people just want to move on, not go back there. But it seems like we're still in certain pockets within public health litigating what happened in the pandemic. And there may be some independent commission that we have in the U.S. There's already been reports on this, but I think from an indoor air quality and infection control standpoint, I've written about this before, but there's just a willful blind spot in terms of the importance of indoor air quality within the broader hierarchy of public health concerns that needs to be addressed. We are all breathing hundreds of gallons of air per day. And it's the quickest exposure pathway for many contaminants. But then you look at kind of how much are we putting into public investment, to the standards and regulations, to making this an area where we're responding in a way that's commensurate with the risk and the importance. And I think it's still not even close to where it needs to be. And to the extent that these reckonings don't devolve into just complete hyper politicization and polarization, and there's a good faith kind of constructive element to them, I think we could see advances. But that's being a bit of an optimist. I don't know. It can also go in the complete wrong direction. And, I think that for the people who care about this issue, you have to come off the sidelines and in your own way engage in these debates to help steer them in the right direction. And that's kind of how we view our role at Safe Traces, is push it. There's going to be a lot of noise and a lot of bad things, but you got to be in the fight. You got to be in the debate. So,
and as Kath Noakes beautifully put, who was involved in the UK fight against COVID, and similarly where I was in Ireland, what COVID asked of us was, what do we know about our buildings? And the answer was resoundingly, absolutely nothing whatsoever. And that gap is universal. Right. Now, some may perform well, some may perform poorly, some probably in the spectrum in the middle somewhere. But the trouble is, until we know, I scribbled down earlier on as you were talking, what managing risks ask of us is, am I doing everything today that can be reasonably expected with the resources that I have? Mm-hmm. That's all that risk management is. Right. There's no such thing as zero risk in this world. And in the built environment, we're not going to have a perfect built environment. The question is that, are we doing everything that can be reasonably asked of us with the resources that we have available? And those resources will be different for different sectors. But you've got to start from that premise, and it starts by understanding the spaces that you've got. And as you pointed out really well, sometimes with limited resources, it's not about the fact that you can't fix everything. It's about knowing where to direct the limited resources that you have got for the maximum effect. And that's what this is about. And I think that's what's fascinating. That's what's so fascinating about your product, is that ability to visualize that. Eric, look, it's been absolutely brilliant talking to you this afternoon, stroke evening, morning, actually, I think, where you are. So look, I really appreciate your time. It's been fascinating as always, and we've eaten into 2 hours without missing a beat, which I knew was going to happen. Listen, thanks a million. Really good talking to you.
Oh, thanks so much for the opportunity, for the great discussion. Thanks for everything you're doing. I think that your ability to communicate on this issue, given your both extensive subject matter expertise, but also making it accessible to lay people and to being a real locus for top people in the field to come to. I think it's huge, and it's been absent, I'd say, for the most part, in terms of having this type of quality communication platform to be able to speak to both the community of practitioners and experts, but also extend beyond. And so I think what you're doing is extremely valuable, and excited to see you continue to grow and do great things.
Well, look, I really appreciate that, but this is on the back of amazing people. The privilege is mine, and it's been a privilege to speak to you this afternoon, morning, I guess. What time is it there? Must be morning.
It's 4 minutes before noon, so we're going
perfect.
From one
just
to
in
the
time
other.
to go and grab a coffee and some early lunch. Eric, thanks a million. Speak soon.
Thanks so much, Simon.
Take care. Thanks for listening. Before you go, can I ask a favour? If you enjoyed the podcast and know someone else that might enjoy it too, do spread the word and let's keep building this community. The podcast was brought to you in partnership with Eurovent, ACO, Erico, Ultra Protect, 21 Degrees and Imbiot, all great companies who share the vision of this podcast, and your support of them helps them support this show. Do check them out in the show notes at airqualitymatters.net, and do also check out the YouTube channel by the same name, with loads of extra content appearing on there weekly. Thanks a million. See you again next week.